Hello. Um, in this short video, I will tell you about the course coverage or outline of the course on electrical machines 1. In this course, primarily two topics will be covered. One is on transformers and the other one is on DC machines. Transformer, when I say, we will be mainly discussing about the power transformers, the transformers that operate at 50 hertz. And transformer being a static device, its efficiency can be very large, maybe 99% for large transformers is this value of efficiency is not uncommon. And transformer, as you know, it transforms one level of voltage to another level voltage, keeping the frequency same, and power in both the primary and secondary windings in a two winding transformers, that also remains same. And transformer is an integral part of the modern day power transmission and distribution systems, and it is widely used. Okay? Whenever you need a change of level of voltage, a transformer is to be used. Now, therefore, it is worthwhile to study transformer slightly in detail. So, we will begin with the operating principle of a transformer, and then we will discuss about the concept of ideal transformer. And before we really start transformer, another small topics we will just review, that is called the magnetic circuit analysis. Okay, a magnetic structure, there will be coil wound if it carries current, how to calculate the flux that will be established in the core, or conversely, if flux in the core, for a desired flux in the core, how much current is needed in the coil. These are the topics of what is called magnetic circuit analysis. So, we will briefly discuss about that. Then transformer, a two winding transformer basically is a two coupled coils with self inductances L1, L2, mutual inductance M. Therefore, a discussion on coupled coils and inductance values, how they are related, will be discussed. After that, we will start with an ideal transformer. An ideal transformer is a transformer which has no losses, no winding resistance, no leakage flux, and then we shall try to find out the equivalent circuit of an ideal transformer. Ideal transformer is really ideal, that does not exist in practice. Then, based on the knowledge gained from the analysis of ideal transformer, we shall take up a practical transformer, okay, which is non-ideal, and then we shall bring all the realities present in a practical transformer and add that thing to an ideal transformer to get the equivalent circuit of a, say, two winding transformer. Okay. So, equivalent circuit development is an important part of the course. So, EMF equations, then phasor diagram of course, will naturally follow. Then you develop the equivalent circuit of a transformer starting from the ideal transformer, that we will do. Once you get the equivalent circuit of a transformer, then you can predict the performance of the transformer under various conditions, no load, full load conditions, that is for a given input voltage, what will be the output terminal voltage if a particular load is connected across the secondary of a transformer, those analysis can easily be done, and also we can predict the efficiency of the transformer when it is operating at a particular load. Then there is another important topic which is called the regulation of a transformer, that also can be estimated from the equivalent circuit of a transformer. Now, the moment we say that a transformer has got an equivalent circuit, means that there will be several resistances: primary winding resistance, primary leakage reactance, secondary resistance, secondary leakage reactance, and magnetizing branch of impedance, etc. Therefore, for a practical transformer, how to determine or estimate rather the equivalent circuit parameters of a transformer, that we will discuss. In fact, by doing some simple test called open circuit and short circuit test on a transformer, the equivalent circuit parameters can easily be estimated. Therefore, a transformer, if I know the equivalent circuit, I can predict the performance of the transformer at a given loading condition of the transformer, and also I can estimate what will be the voltages available. So, these will be the topics of the transformers. Now, transformers may be of various types. For example, we will start our discussion with a single phase transformer. Okay? Then, as you know, our power system is after all a 3-phase system. Therefore, 3-phase transformers are also widely used. So, we will then talk about the 3-phase transformers, its constructional features, and the connections. The transformer primary winding may be connected in star, secondary in delta, or vice versa, or star star delta delta. What are the implications of those connections? And a 3-phase transformer connections are specified what is called by a vector group. So, we will also learn about the vector group of a transformer. Okay? And given a 3-phase transformers, how to correctly connect them in a particular fashion. For example, YD1, DY11, these are called vector groups. These also we will discuss in great length. Then equivalent circuit of a 3-phase transformers will be similar to that of a single phase transformer, only thing per phase based analysis is carried out. So, all the things like regulation, efficiency calculations, they are similar to that one. So, 2 winding transformers single phase, then 3-phase transformers which we will switch over, and there is another class of power transformers, that is called auto transformer, that is also very interesting. So, auto transformer essentially has a single coil where supply is given across the whole of the coil, and through some tappings the output are taken. Therefore, a portion of the coil or winding is common to both primary and secondary. So, how to analyze the performance of an auto transformer, its equivalent circuit, these are the things we will discuss. And if you can change the level of the voltage from one value to another, which keeps of course frequency same, you then learn that it can be done in 2 ways. You can use the 2 winding transformers, or you can use an auto transformer. The moment you have got 2 options, the question is which one to choose. Should we choose 2 winding transformer to change a voltage of 200 volt to 100 volt, or should we use an auto transformer which can also change the level of voltage from 200 to 100 volt. Therefore, there will be some issues, or we must understand under what condition to use an auto transformer or under what condition we use a two winding transformers. Similarly, three-phase auto transformers are also used. Therefore, these are the main topics. Apart from that, we will discuss about the parallel operation of transformers, both single phase and three phase. What are the conditions under which two transformers can be connected in parallel, and why the transformers are connected in parallel at all. These are the things we will also discuss. After we have discussed, if we get some time, then we will also discuss about some special phenomena which occurs in a transformer. For example, switching transients in a transformers, okay, magnetic inrush current. These are some topics which, if time permits, I will definitely discuss. So, this is in nutshell about the transformers, and also at the end I will sketch a transformer where what are the fittings they are connected, how to cool a transformer, these I will just touch upon. But main point is the how to analyze a circuit, power circuit, which involves a transformer inside. That is the whole idea. Anyway, so this will be the about 30 units, 13 to half an hours will be consumed by transformer. Next 30 units we will discuss about DC machines. Remember, transformer is also a machine, but it is called a static machine. As I told you, efficiency of transformer could be very high because it is static. There is no rotating part in it. Therefore, its efficiency can be very high. On the other hand, rotating machines which takes electrical input power, for example, motor operation, and then it will convert that input electrical energy into mechanical energy. In case of motors or in any rotating generator, the input power will be mechanical power input and output power will be electrical. So, rotating machines are of various kinds, for example, DC machines, AC machines, primary divisions are like that. Now, DC machine will be the topic that we will be discussing here. So, the constructional features of a DC machine. Any rotating machine will have two structures, one is the stator and another is the rotor part which rotates. On the stators there will be windings, on the rotors there will be also windings, and when the machine will be operating, both this stator and rotor coils will be carrying current and they will produce fields, magnetic poles, and they will interact with each other giving you torque. That is the, in short, the story about all the rotating machines. Now, in case of DC machines, the stator windings will be wound on projected poles, okay? And it is very simple windings, and that winding will be excited by, as the name suggests, with DC or batteries, constant current will be flowing. The armature winding is somewhat complicated. In the sense, unlike AC machine winding, armature windings will have coils, no doubt, housed on the slots in the rotor, but these windings will be terminated on commutator segments, and output of the armature terminals are taken from brushes. Okay? Therefore, the constructional features of DC machine is very important. After we have discussed the constructional features, we will develop the EMF and torque equations of DC machines, which may operate both as motor or as generator, and these things I will take simultaneously, these two options. Then the characteristics of DC generators and characteristics of DC machines we will take up. Then we will talk about the equivalent circuit of the DC machine, okay, and how to calculate the efficiency of a DC machine, what kind of test we have to perform. Now, DC machines can be classified as a shunt machine, series machine or a compound machines. So, the characteristics of all these types of machines and their relative advantage and disadvantages we will discuss. So, armature reaction, for example, an important topic in DC machine. When armature carries current, it will also create flux, and as I told you, any flux component along the brass axis creates problem. So, that is called commutation problem. The ill effects of armature reaction, how to nullify them in a DC machine, I will also discuss. You can use the compensating winding or interpoles. So, the characteristics of separately excited DC machine, shunt excited DC machines and other series generators are also there, but limited use. So, those characteristics we will discuss. Similarly, shunt motor, series motor and compound motors, the characteristics of them we will briefly discuss. And if time permits, we will discuss about several kind of testing on DC machines, including Hopkinson test. So, I hope you will like this course, and this course will be supported by some lecture notes that I will write and provide you as the lecture proceeds, and we will have interaction among ourselves, so that any queries on your part will be discussed specially, and also there will be tutorial session, extensive tutorial session on this course. Last word, in case of AC machines, equivalent circuit is somewhat difficult, involved. Analysis, calculations are also difficult. In case of DC machines, it is the other way around. Construction is difficult, but computation is very simple, and this is how the lectures will go on. Thank you so much for your patient hearing.